What's going on, YouTubers? Daniel Dallas right here. So thank you for your views. I actually got about 100 views for just 1 week. Thank you guys for appreciating me. So actually, as I promised to you, we need to finalize our topic dedicated to sequence, and that's the first self-practicing exercise dedicated to part 1 sequences, like general idea. All right. So here are several exercises. I got it from GCSE past papers, trying to arrange them. And now it's right time to try yourself and how well you understand this topic. Let's go. First, here you need to write down a rule to describe the sequence and find its next 3 terms. Alright, so actually if we're successful in finding 2 terms, that's okay. So right now we're just checking them up and trying to see at the difference. Remember, a general promise, check the difference. Alright, so let's do it. So the difference, 5, 8, 11. Let's try to do. By the way, for those who can do it by their round, so pause the video and try to see what they have next. Alright, and just comparing the results. So here we go. First, about the difference, 5, 8, 11, 14. Okay, so successful difference, 3, that's not changing. So if difference is 3 and it's not changing, what we can say definitely arithmetic sequence. So we know the rule. So every time to the previous term, we need to add 3. So it looks like plus 3, and we go 20, then 23, and 26. All right, done. So next one, 2, 9, 16, 23. If we apply the difference, we see that difference for the first one, 7, for the next one, 7, 7, and so on. So every time add 7, and that's how we can get the following terms. All right, 44 and 51. So next one, 38, 34, 30. All right, check up the difference, 38, 34, 30. So the difference is negative in this case because your elements, your terms are going down, so it means decreasing. In this case, we just subtract 4. So every time we just subtract 4 and 38, 34, 30. So we got minus 4 every time. So we'll get 22 minus 8 minus 4 is 18, and then 14. All right. So soon you reach negative elements. That's okay. So next one, 8, 19, 30, 41. All right. So let's try to check up. So the difference is 11 here. So 11 here, 11 here. That's okay. So every time add 11. So that's how we can get the following terms. So the following terms when we add 11, so it's going to be 63, and we're just doing the same. All right, it's done. So next one, write down a rule to describe the sequence and find its next 3 terms. All right, typical task. So let's do it. 3, 6, 12. All right, if we apply the difference, so the difference is 3, then difference is increasing, is 6, so the next difference is 12. So looks like something going on. The difference repeats numbers itself. So what it means, the difference method is not applicable here at all. So what we can do, we can start thinking about multiplication, because you see 3, 6, 12, 24. So it looks like we can multiply by 2. Again by 2, again by 2. Yeah, that works. So looks like the following 3 terms going to be. All right. So 48 multiplied by 2. So the rule here is every previous term multiplied by 2. So the next term becomes 96. All right. So next term becomes 192. All right. So next term just multiply by 2. I want to do that because it's about calculator. You got a principle. All right, so C, E, F. All right, so 2, 10, 50, 250. Let's find a difference. So difference obviously doesn't work here. So what about multiplication? So 250, 250. Does it work? Multiplying by 5, right? Multiplying by 5 again, and by 5. All right, so the same rule. So we're just multiplying by 5. All right, I won't write those elements. So next, E. So all that done. 162, 54, 18, 6. Let's see what we can do here. So 162 and 54. So probably it's about division, right? So we start from 162. If we divide by 3, 162, if we divide by 3, we exactly got the next term. So 54 by 3, that's 18. 18 by 3 is 6. So it looks like, of course, instead of division, it's weird to use division, right? In the sequence. Even in geometric sequence, you saw that it's multiplication, but by a fractional number. So it looks like we need to multiply by a fractional number, and fractional number is 1 over 3. All right, 6 by 1 over 3 is 2. So 2 by 1 over 3 is 2 over 3. All right, that's how it works. So, E done. F, let's do it. 405, 135, 45, 15. Let's do it in very fast manner. So 405, can we divide by 5? By 4? No. By 3? Yeah, looks like we again apply 1 over 3. So let's check it here. 45 and 15, that's working. 45 multiplied by 1 over 3, it's cancelled, right? And gives you 15. All right, that works. So it looks like 1 over 3 again. So it's going to be 5, and the next term is 5 over 3. All right, you see fractional numbers, but that's okay. Okay, the next set of exercise. Find the next two terms of. All right. So let's see what we can do here. 0, 1, 4, 9, 16. Oh, yep. That's good. So you see, guys, what sort of numbers you can have there? Obviously, square numbers, right? We have deal with square numbers. So square is just something that multiplied by itself gives you a square. All right. So how to get, for example, 1, just 1 by 1, right? 1 by 1. So 4, 2 by 2, 2 squared. 9, 3 squared. So 16 is 4 squared. So looks like it's going to be 5 squared. That gives you 25. And next is 6 squared, so 36. No problem. You see, the logic has been changed. But actually, you easily can connect with a number. Let's do it. So if we have counting numbers, like that's the first, that's second, that's third, that's fourth, and we have 0 squared, so 1 squared, 2 squared. You see that counting numbers and elements in the base, so that's the base, right? They're connected like counting numbers shifted ahead by 1. So it looks like you can even generalize. Let's see the general formula. So it looks like n minus 1. So counting number minus 1 squared. Let's check it. For example, we choose, let's say, fourth element is going to be 4 minus 1 squared. Yeah, it works. 9. So you see, you can even generalize the formula, and that's good if you can do that. All right, let's move next. Okay, so the first done. So next one, 149. Oh, obviously that purely square numbers. So it looks like, so it's 5 squared. So next is 6 squared, 36. And then it's 49, 7 squared. All right. So let's take C. 1, 0, 1, 8, 27, 64. Yeah, they're definitely not square, but I'm just looking here and I understand that they represent cubic, right? Cubic numbers. All right, so cubic number is just a cube. So 2 cube, 3 cube, 4 cube. All right, so let's check for 1 and 0 cube. All right. That's how you can present. So next goes 5 cube and then 6 cube. All right, that's how it works. So cubic sequence. All right, so fractional 1 over 4, 1 over 9, 1 over 16. Let's do it. Okay, the same but as the fraction 1 over 2 squared. So for 1 over 9, it's 1 over 9, 1 over 3 squared. squared, all right? And looks like here is going to be 1 over 25. It's 5 squared, so it's going to be 6 squared. 6. Yeah, let's just diminish our size. So 1 over 6 squared, or that means 136. So next, and 1 over 49. Good, perfect. So 1, 2, 4, 7, 11. Okay. There are definitely no square numbers, but let's check the difference. All right, so the difference is 1, 2, all right, 3, 4. So you know the difference just increasing by 1, so you can get the logic. So it's going to be, so next difference should be 5, and here difference is going to be 6. So 11 and 5, 16, and next is 22. All right, so difference is increasing, but if you want to, so you can even generalize. So the second difference, delta 1, is 1, 2, 3. So the second difference, delta 2, difference of difference, 1, 1, 1. So it's constant. So it looks like it's just quadratic sequence, all right, because the second difference is not changing. You see how you can apply really a lot if you just know like all those 4 topics that I gave to you. It's really fruitful instrument, so, or tool, so you can use it, and now your knowledge is really extended. It's not just standard GCSE level, you can go beyond even in just extended level. So obviously that's definitely fruitful. All right, so next F, let's go. 2, 6, 12, 20, 30. All right, so what's going on here? So 2, 6, every time here is the first multiply. That's not working. Yeah, I just saw it multiplying by 3, but this doesn't work. So what we can do, so probably we can, let's see. So sometimes solution is not like seen, it's not straightforward, but anyway, you try to see. So 12, 20. Okay, let's just calculate the difference. So actually thinking, but I cannot do like fast. So 2, 6, the difference is 4, then 6, then 8. All right, so 10. So it looks like the next difference is 12 and 14. So difference changed by 2. So every time it just by 2. So all right, so difference of difference is 2, 2, 2, 2. It's constant. So it looks like it's correct, but you just need to at least several next terms. All right, 2 terms in this case. So 30, 42, and next difference is 14, so 56. All right, you see, so this sort of sequence pretty hard, starting from like simplest way, then just go to where difference is changing. All right, so we've done completely that one, and now we just move down up to write down the rule. Okay, so if you fix that result, just erase, and here we go. Next, so what we have write down the rule to describe the sequence, find next 3 terms. All right, so rule, how to find the rule here. Okay, so A, 1, 1, 2, 3, 5, 8. Okay, I've got it. This is sort of Fibonacci sequence, all right? So Fibo are specific numbers. So actually, if someone had an experience with stock markets, there are specific like Fibo net when you, for example, your index, let's say, is falling, just deep crisis, and then someone decide that's enough, like those leading people who owns 5% of wealth, all right? So they decide that's enough, so we have a strong buy here. All right, there is specific analytic tool that's designed using Fibonacci sequence or Fibonacci sequence. There are sort of levels, and you know what's happening, so they go a specific like percentage of reflection, and they might be like more realistic, it's kind of like average level, but in Moore's case then just go like a bit more or higher. So that's reflected wave. So that's like deep fall. There was deep crisis, but when strong buy, then when later people decide, okay, we need to buy, so investment funds also buy here somewhere a bit higher. So, and that's how actually buyer waves or bullish waves on stock markets occurs. So it goes backwards, and here is might be possible reflection if like many people decide that, lots of people decide that that's not the end, or those who strong buy actually change decision and see it like macro news on a macro level, decide again to have a bear position, means they playing down, all right, they short. So actually they stay in short. Those who strong buy stays in long position, all right, and that's so the price might just keep going. So you see that Fibonacci sequence is actually very applicable. All right, so but now let's go back to abstract math. So here, what we need to do, why Fibor? So for Fibonacci sequence, the next term, let's say 2, is the sum of 2 previous terms. So 2 is basically 1 and 1, because 2 previous terms, 1 and 1. All right, so let's go to 3. So 3 is sum of 2 previous terms. So this one and this one, all right? So 3 is just 1 and 2. So obviously 5 is 2 and 3. So 8 is 3 and 5. So next term is the sum of 5 and 8. And it occurs to be 13. That's Fibonacci sequences. So you're not obliged to know the formula for that, but so the general rule here you can set up as un is 2 previous, means un minus 1 plus un minus 2. That means previous and pre-previous, all right? So you need to sum them up. Okay, and next term is 8 and 13. So it looks like it's 21. All right, that's Fibonacci sequence. You need to know that. So 1, 3, 4, 7, 11. Let's see the difference. Okay, so let's see how it works. The difference is 2, here is just 1, here is 3, here is 4. Oh, that's real massive, because the difference first like 2, then it's decreasing, that's increasing again. Okay, let's check the second difference. So the difference is -1, difference is +1, so +1. Okay, it's not like steady. So that's why you need to think using different, so apply using different logic. Okay, what we can do, so let's see one more time. Okay. Oh, that's actually Fibonacci sequence. Yeah, it wasn't apparent from first glance, but look. So 1 and 3 gives you 4, right? Let's erase those. First wrong approach. So 1 and 3 together is 4, right? So that's Fibonacci definitely, because 7 is again 4 and 3, so 11 is 4 and 7. So next two terms, let's work it out. 7 and 11, that's 18. So next one, 18 and 11, yeah, become 29. All right, that works. Oh, C, mark like super hard. Okay, that's for definitely a star. Okay, so 5, 8, 12, 18, 24, 30. Okay, 5 and 8, 3. So that's definitely not supposed to have a constant difference or difference of second level. I guess that's something new. Okay, so 5, 8, 12, 3, then 5. So 5, 8, 12. It's not Fibonacci because 5 and 8 is not like 13. 8 and 12 is not. Okay, maybe. So maybe it's kind of Fibonacci but adjusted. So it means, for example, 12. Let's consider how it might be arranged. So 12 is 5 and 8. It's 13, right? But you need to subtract 1. All right, so let's see how 18 might be a range. So 18 is 8 and 12, right? So 18 is 8 and 12, so two previous terms, but you need to subtract 2 instead. So let's say 24, whether it works in the same manner, like subtracting 3. So 12 and 18, no, it doesn't work. Like 24 is 20, 12 plus 18, but minus, not 3, sorry. Maybe minus, so it should be minus 6 actually, yeah. But the logic is broken, because here you understand that every time what you subtract actually increases by 1, or at least times 2, but you see it's not times 2 and it's not like plus 1, so it doesn't work. No, that approach failed. All right, so let's think differently. So 5, okay. Okay, let's consider maybe sometimes, you can decompose each element into, now let's say, sum of other elements. So 5 is 2 plus 3. So 8 is 3 plus 5, right? It works. So what I notice here, 3 on the edge, like on the boundaries, repeating. So 12. See how we can arrange. So 5, we need to repeat 5 definitely. We add 7. Oh, you see it works actually. So let's take 18. So 18 is 7. You just repeating the boundary, but you need to add next term. But 7 plus 9. So I thought like the difference is 2 everywhere. Here is 1, here is 2, but here is 2. So who knows? But actually it looks like odd numbers everywhere, but except for 2. So maybe prime. So you set up the question, maybe they're prime numbers. Okay, so the next prime number after 7 is 11, right? Yeah, I think I got the logic. So 11 plus next prime is 13. Does it work? Yep. Actually, yes, it is. So looks like the logic why I see like red, because it's really hard to just figure out that exactly each term is a sum of specific prime numbers. So 30, let's finalize to have more confidence. So 30 is 13 plus next prime is 17. All right, yep, it works. So you can generalize. So current term, let's say you add the sum of two primes. So prime like 1 plus prime 2, but actually you less likely, for you it's less likely that you can like give a general formula. Right, yeah, we can probably try, but this is not the question here. So we just need to, it's not like even like GCSE level. It's definitely, this C is for extended level, definitely. But, maybe somewhere it might be like as 21st, 22nd problem where you need to prove something. Maybe you'll be given the formula, but okay, so let's skip that and just find the next two terms. All right, so here should be 17 is the last boundary plus, so it looks like 23. Yeah, let's check it. Yeah, I think so. Let's see. Yeah, because so 21 is definitely not. We just want to figure out that it's okay. So 17, right? We arrived at 17. 17 plus 23. And it looks like, how much is that? So actually 50, yeah? So one more time, 13. Oh, I messed up. Sorry. Because I just was thinking about like from 17, but I just stuck a little bit. Right, sorry. So 17 and 18, that should be right, because the next prime is just 19. 17 plus 19, that's right. So let's see, 17, 19 is 36, all right? So next one is going to be 19 here, definitely 23. It's going to be 52, all right. Yeah, it's 52. Oops, my fault. Bad calculation today, sorry. It was hard work, weekends. All right, so 1923, so 42, my fault. All right, so by you have calculator, you can do it definitely more proper than me. And you beat me here. All right, so we've done everything relating to numbers, right? Number sequence. So, okay, so draw next to matchsticks, all right, figures in this sequence and write the number of matchsticks used. Okay, so probably you, less likely that you need this on examination. But anyway, so it looks like, you know, stuff for 7 notes, for like King's School, maybe Imperial College. It's like general, like broad knowledge and general logic. Okay, but anyway, we'll try to approach this problem first. Visually, we just trying to draw what actually is supposed to be here. And then we just count the, so we need to write numbers matchsticks. So we can also consider it as number sequence. So first, okay, let's do visually. And you see that the first like 3 sticks, and then you add just the same pattern. So it looks like here is going to be like 4 kind of brackets, right? Square brackets. And obviously, so there are 5, and that's going to be like 6, right? So, but because each pattern, each like bracket has actually 3 matchsticks, you can use the pattern as following. So 2 times 3, so basically 3 and 3, it's going to be like 6, or just basically multiply number of those like basic symbols, that's the basic, like containing 3 matchsticks, and multiply by number of patterns, you multiply by matchsticks in each one. So it's going to be like 3 by 3, it's going to be 5 by 3, and 6 patterns by 3, all right? So that's going to be the logic, okay? But now let's try to figure out. So 15, yeah, and next, okay, 18, yeah. Oh, okay, so actually you need to give next 2 matchsticks, yeah, that's okay. So 4, yeah, for next one, 5, all right. So B, okay, so we have basic one, but we're sure that we add, actually, what we adding, we add 3 sticks. So let's just calculate number of sticks. It's better. So right now, how many sticks we have? We have 7, right? 7 sticks. So 7 plus 3 is going to be 10, right? So next one, we have the whole pattern here. And we know that's 10 sticks here. So we add 3. So every time we actually add 3 sticks, that's easy. So difference just plus 3, positive 3. So we add 3 and we will get 16 and then 19. All right, so 19 matchsticks. Let's go to C. All right, so 1. Okay. So here, do we need to describe the rule? Use this number sequence? No, we just need to draw. Okay, draw next to patterns. Okay, so here we actually notice that every time to like the central pattern, we add from left, from right, and from bottom part. But actually, it's better again to go to number sequence and figure out what do we have. So here we have 4 sticks, 4 matchsticks. So next one. Okay, so it's going to be 13 here. So next, okay, we have this pattern, so that's why it's easier to highlight the pattern that we already have and just add by 3 sticks. 1, 2, 3. Oops, not by 3 actually. So here is 3, here is 2, 3, 2, 3. Okay, so looks like to 13 we need to add 26. It's going to be, sorry, 26, that result. So to that 13, we need to add 13. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, so 26. Okay, so next one, how many matchsticks will be in the next part? Okay, so what sort of sequence? 4, 13, 26. So the difference is 9 here is the difference is 13. So 9 13 is actually 4. So do we need to add like 17? That's the question. So I bet it's going to be, so the next difference, so difference between differences is just 4. So it looks like the next difference is 17. So 26, because it's like 4. So 26 and 17, you just need to add, right, in order to get 43. So it looks like the next part should have 43 matchsticks. Let's check it. So probably, you know, that having like only 3 terms and having just 2 difference and 1 difference on second level, that's is not changing. It's not like really representative, because the next term, if it's not like 43, while it might change your pattern and change your initial idea. So that's why you need to check in terms of like visually what's happening actually. So I can generalize the rule in the following. So if we have like basic pattern, we add on every side except for top. So this sort of bottom line, you don't touch it. You just don't go over that level. You just add 3 patterns from left, from right, and from the bottom part. So it looks like here you need to add this one, this one, this one, this one, this one, all right? So if I drop what's going to be next, so it looks like you just need this one, you actually add this one. Let's erase for a while. We've got the number, so we just need to check it. Okay, so here, 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 and here, right? And to do the same from left side. Okay, so let's see, is the right picture? So how many sticks we have? So we have the basic part in 13, and we just add, oh, that's really hard to calculate. So 1, 2, 3, 4, 5. So one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So boom, 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 boom. 30. Yeah, I said. Okay, so looks like it's 43, but I didn't count up to the end, so that's the problem. So do we have like a round number? So let's do it one more time. So we have 13, yes, and here just from each side we need to add the square, right? So but because we had it originally here, so everywhere square on top of that, so black ones. Okay, so maybe, yeah, so what we can do, we just need, okay, let's count the bottom row. 1, 2, 3, 4, 5, 6, 7, right? Yeah, so I think it seems to me it's correct. So if you can count properly, I don't want to waste my time, so I bet that number is 43 due to like my logic. So but you can check and so give in comments if you can. So how many like sticks actually in the third pattern, I mean here. So you just need to calculate how many sticks here. You can do your own way, but so I figured out through just numbers, through number sequence, that's 43. All right, so it looks like the next term is going to be like difference, the next difference is going to be 21. So if you add, it's going to be something like 64, right? So the next term should be 64. All right, so check those numbers and just write in comments what do you think about this way. So, okay, let's move next. Here we go. So D, all right, so D, we have like this basic shape. So you can see it here, here. So that's one shape, another shape, and we just add like top sticks. So basically this pattern has 1, 2, 3, 4, 5, and then we just 5 times 2, because we have two shapes, two basic shapes, and extra 2 top and bottom sticks. So it looks like 5, 2, the answer is 12. So here is going to be like 12 matchsticks. Let's see what's going on here. So 1, 2, 3, so 3 basic pattern. 3 times, so 5 times 3 to be consistent. All right. So 5 times 3 in add, not just 2, but how many sticks? 4, right? So 2 times 2. So the resulting number is 15, 19. All right, so we have 19 over here. So let's see what we have. 5, 12, 19. Can we figure out probably the difference? So it looks like it's sort of 5, 12, so 7, 7, so 2. Well, we have 7 again. Okay, so here is pretty easy to draw the next pattern. So we just draw the basic shape, right? Okay, we can see that one. So our previous, so okay, and so it's better actually to draw up to the previous pattern. So okay, draw up. So every time plus 1 shape, right? And extra 2 sticks. All right, so we know that's 19 up to, so purple sticks, and let's count black one. So again, 1 new pattern. So it looks like 5 times 4, because we have like 4 patterns. And here we need to calculate the number of sticks that we added. So in total, like 1, 2, 3, 4, 5, 6, 7. So we add actually 7, and next number should be 26. So I bet it's 26 here. So it looks like the difference actually is not changing, so it's constant. That's definitely arithmetic sequence. All right, but the rule here that we know is 5 times 3 plus 2 by 2. So here is 5 times 4, and add, looks like 2 times, so we have 20, right? 2 times 2 times 2, yeah, that's the pattern. Okay, so even here you can generalize the formula because it's arithmetic sequence and you see the rule. Now that you actually can derive the general formula, but you are not asked. All right, so let's go here. So E, okay, so it's easy. The next pattern should have like 4 houses, something like that. In terms of sticks, so 4 into 6 here, then so 6 and 6 without just 1, right? So because I just consider like houses. So the basic pattern is house with 6 matchsticks, but then this one is just the common stick for 2 houses. So actually 6 times 2 and subtract 1, so I've got 11. So if you want to recount, so here we have how many sticks? Like before, in the third pattern we have like 3 patterns, so it looks like 15, yes, but 2 sticks common, right? So it looks like 15, no, 16. Okay, let's check it. So 11 here, and we need to add 1, 2, 3, 4, 5, yeah, 16. Okay, we've got a sequence. 5 has the difference everywhere, so I bet the next difference is going to be 5, so next term is 21, and next term is 26. All right, so check it, but I hope it's okay. So next one, okay, next one. Actually, before, it's very similar to what we had in C, I mean here, but there it was like on sides and one on bottom. Here, just everywhere, so everywhere. So let's count number of sticks one more time. So 4 in basic pattern, then 3 additional, 3 times 4. So that looks like, so 4 plus 3 times 4, right? So we've got 16 here, right? So 16, so we've got a pattern. sequence 4, 16, and next one. So next one, let's see what's next one. Boom, 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 boom. All right, so we've got the basic part here. This is the previous element, and we had 1, 2, 3, 4, 5, 6, 7, 8. So it looks like it's 4. Oops, the previous part, yeah. The previous part is 16. And 8 times 3, yeah. So one more time. 1, 2, 3. Oh, okay, that's a gain. Yeah, that's a gain because actually, yeah, just count properly. So never mind, because you see here on edges there is 3, but here is 2. So 3 again 2. So it looks like you just need to count like those sticks over there. So we've got 16 here in the black pattern. All right, and we add just outside. So let's do it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So looks like it's 36. All right, so yes, so 4, 16, 36. So what's going next? I bet it's gonna be like 64. So like so 4 is 2 squared, yeah. Here is 4 squared. So 36 is 6 squared. So next it should be 8 squared. I've got a sequence. All right, that's why it's 64. And next one is gonna be 10 squares, so it means 100. All right. So that's the sequence. You see, the rule is quite interesting. All right, so let's do the last task, the last problem here in this set. And this actually really covering everything that we did in those 4 parts. All right, so draw the next 2 figures in these sequences and write the number of dots, use the number of sequences. All right, so draw the next 2. So here are central points, and we add just the lateral side to each one. We add again on top here and here and here. So it looks like we're just adding. So, but it's better to use again numerical sequence or number sequence. So let's see. So 1, 3, and again 3, 6. Okay, 1, 3, 6. So the next one, so that's the basic part. We just count new one. 1, 2, 3, 4. Okay, so 10. Let's see. So the difference is 2, 3, 4. All right, the next difference 5. So we got 15, and the next number is gonna be 21 because 21 here because we need to add 6. All right, so that's how it works. We've got the logic, we've got the rule. So let's erase and see it back. B. So 1, 4, again 4, 3, 2, 5, 9. All right, 1, 4, 9. So looks like square numbers. And next one's going to be 16. So next one's 25, right? Okay, again, this is the logic of square numbers. 36, next one. So that's B. C, okay, 1, 4. And here we have 9. And next one, I bet it's going to be 16, then 25. All right, so you know the square numbers. Okay, in the last part, so what, several seconds, so 2, and like externally 2, 4, 6, yes, it's 8. Next one, so that's the basic part in here. All right, so we just do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like 18. All right, what's going on here? 2, 8, 18. Okay, what sort of sequence? So 2, 8, okay, maybe times 4. That's time. No, time doesn't work. 2, 8, 18. So 2 cubed, no, that work. So okay, let's see difference. 2, 8, 6, 10. So probably the next difference. So 6, 10. It's 4, 14. I bet it should have 32, but I'm mistaken. So actually, how we can do that? So graphically check this number. Yeah, because this is just my assumption. I see that every time we just need to add 4 between the difference. So it looks like it's sort of like square quadratic sequence. So next difference, it should be 4 more. So it looks like we need to add 18 in order to get 50. So I bet that 2 next parts should have 32 and 50. All right, so great job has been done. So look what we've got. We've got just all like sort of sequence and different types, and actually we did it. So thank you guys one more time. I just want to write here in bold. So thank you for your support. I actually created a video for you guys, and I'm really rewarding of your views. Some of them just trying to give some comments. That's okay, that's normal. So I hope this video was really helpful for you. And just for next time, we just do self-practicing in part 2. We actually had arithmetic sequence, so probably it's not like a very big topic. So an arithmetic sequence, I just show several examples and we go through them. And actually for geometric, it's also not so lots of quantity of examples to go through. It's pretty like intuitive, understandable, and clear. So that was like the real hard, because here you need to generalize and apply switching from one rule into another. All right, so thanks, and hope in a few days I'll just create the next sequence video. Maybe I can bind sequence 2 and 3 at once. Hope you enjoy, and see you later.